Welcome to Integrated Math 1. We're going to be taking notes today on solving equations. This is our first notes of the year, so it's exciting. We're working in Unit 1, Quantities and Modeling, and Module 1, Solving Equations. And this is Lesson 1.1, Solving Equations. So what we're looking at today is our essential question is how do you solve an equation one variable? And in our math, we're going to be mostly working with solving equations in one variable, but later on we will start looking at two variables. So some definitions you need to be comfortable with is equation. And an equation is a mathematical sentence with a solution. So let's go ahead and write that. So an equation is a mathematical sentence that has a solution. And you've seen a lot of equations. Like you should be familiar. If I asked you to write you an equation, you should know how to write an equation. And just to write an equation, for example, would be like 2x plus 1 equals 7. We looked at this in class yesterday, but that would be an example of a mathematical equation. I'm just going to change the color so you can actually see it. There we go. Now, the solution of the equation is the answer to the equation. So solution to an equation is just the answer to the equation. So let's write that. Pretty straightforward. So if I asked you for the solution to this equation, you would give me the answer to the problem that we have there. So for example, again, we got 2x plus 1 equals 7. Well, the answer to that solution, to that equation is x equals 3. Because you subtract 1, you get 6. Divide by 2, and you get 3. So solution to an equation is the answer. An equation is just a sentence that has a solution. So we got to talk about the properties of equality. And you got to notice we got this note on the side that says to find the solution of equation, we must use the properties of equality. And this is just a different name for inverse operations. So what this means is that if I add a number to a number, I have to do it to both sides. So if I look just at letters, we're going to do it with algebra first, so you have the algebra definition. This means if I add, for example, 3 to a, that is still equal to a plus 3. That's all it means, right? That looks like it makes sense. That's exactly what it means. So in numbers, if I'm just substitute numbers, that means that 3 plus 1 is the same thing as 1 plus 3. Right? And that makes sense. Even though it's rearranged, they are still the same thing. The subtraction property is the opposite. This one you do have to be careful because obviously 3 minus 1 is different than 1 minus 3. So again, looking at the algebra side of it, this means that if you had subtracted 3 from a, then you have to do it to the other side. And a and b should be the same thing. Again, just saying that whatever you do to one side, you need to do the other. So again, with numbers, 4 minus 3 is the same thing as 4 minus 3. Multiplication property just says that you need to do it to both sides. So if I had 2 times 4, I'm doing the numbers this time because I went ahead and jumped for it, that's going to be the same thing as 4 times 2. Notice that these are commutative, which means that they can do, doesn't matter what way you do it. And again, with algebra, 2 times a is equal to the same thing as a times 2. It's really just getting into the habit that whatever you do to one side, you have to do to the other. Notice that if I just multiplied 2 to 4, that's not the same thing as 4. It's a different number. So to make it equal, using the properties of equality, I also have to multiply it, the 2 on the right-hand side. And then division, you probably figured out. Let's do it with algebra just to kind of stay status quo. For algebra, sorry, I need to drink more water. If I divide a by 2, then that is the same thing as dividing a by 2. And again, looking at example, if I had 4 divided by 2, that is the same thing as 4 divided by 2. It seems pretty straightforward and like you probably don't need it, but it's just having this here because going ahead, we're going to use the addition property. It just means that whatever you do to one side, you have to do to the other. So if you're using the addition property, you're adding to both sides. If you're using subtraction property, you're subtracting from both sides. The key is that you are doing it to both sides because you're treating them equally. So let's go ahead and jump into an example. We're going to be solving using the properties of equality. And I don't want you to think this is something new. This is just a different name for inverse operations. So in part A, we're given the example 3x minus 2 equals 6. And so it says step 1, we're going to use the addition property. And the reason why we're using addition property is because I want to get x by itself, but I start with working with the thing farthest away from x on the same side of the equal sign, which in this case is 2 or negative 2 because that negative sign goes with it. So in order to get rid of negative 2, I have to do the opposite of negative 2, which is positive 2. So using the addition property here, that means I'm adding 2 to both sides. So plus 2 on the left, and then plus 2 on the right. And then when I combine like terms, I'm just doing the math, right? Negative 2 plus 2 is 0. And 6 plus 2 is 8. So when I get done, I get 3x equals 8. Now I have to do the last step, which is the division property. And the division property just means that I'm dividing both sides by a number. Well, in this case, I'm not going to divide by 8 because remember, I'm trying to get x by itself. So I'm going to divide both sides by 3. So because again, division property, we got to stay equal. So I'm going to write 3. But I'm going to show you something cool that I'm going to do in a second. Well, it's actually not that cool. I'm just using the line tool. And then put that there. There. So I'm dividing both sides by 3. Well, 3 divided by 3 is 1, and 1x is the same thing as x, so that's where this x comes from. But 8 divided by 3 is not a pretty number, and one of the things I want you to get in the habit of is just leaving it as a fraction. I don't want you to simplify a fraction. In the big people world, we don't really want a bunch of random numbers. We just want a nice little fraction. So really, your answer is 8 over 3, or 8/3. If you want to simplify it, go for it, but I am looking for the 8 over 3. Okay. So the solution to the equation is 8 over 3. And we are going to write the solution to this equation because I want you guys to get familiar with that vocabulary. So that's the answer to the first one. I'm going to box it so we know we're done. Bada bing, bada boom. Oh my gosh, look at me doing it on the wrong thing. Okay. Just want to move you. How do I move? Oh my gosh. It's taking too long. Okay, there we go. Did it. Yay me. So next one, we have 1/2 z plus 4 equals 10. And usually when you see fractions, you guys start freaking out. Don't be afraid. We're doing the exact same thing. It's just instead of using the division property, we're going to use the multiplication property. So we're going to start by using subtraction. Hopefully you know how to use why we're using subtraction. Again, it comes back to this. We're trying to solve for z. Thing farthest away from z is 4. So to get rid of positive 4, I subtract 4, which is why I'm using the subtraction property. So subtract 4 from both sides. Remember, I'm doing it only to the 4. And then on the left, I'm doing it to the 10. And then I'm going to do the math. Well, 4 take away 4 is 0. So I have 1/2 z. And 10 take away 4 is 6. So I'm going to put 6 in this next spot. And then I want you to notice how I put 2 times right here. I put 2 times here because in order to get rid of this 1/2, I have to multiply by the number in the denominator or the reciprocal. And the number in the denominator of this fraction is 2. And the reciprocal of 1/2 is also 2 because that's just, remember, reciprocal is when you flip the fraction. So you would get 2 over 1 and 2 over 1 is just 2. So in order to get rid of the fraction, I'm going to multiply both sides by 2. And what that does is 2 times 1/2 is 1 because half of 2 is 1. And 2 times 6 is 12. Well, 1z is just z. And 2 times 6 is 12. So I actually am at my final answer now where I have z is equal to 12. So the solution to the equation is z is equal to 12. Again, boxing our answer. Hopefully I boxed the right thing this time. That'd make my life a lot easier. There we go. So that's just some straightforward examples. Your homework is going to be very similar to that. So let's jump into a real world example because math's not really useful unless you can apply it to the real world. So in this situation, we have an airplane that descends in an altitude from 20,000 feet to 10,000 feet. A gauge at radar traffic control reads that the airplane altitude dropped 1.8939 miles. We want to know how many feet are in a mile. We're going to let M represent the amount of feet per mile. So first, we're going to start with calculating the feet descended. So I am going to start with saying that I need to figure out basically, how many feet the plane dropped. So remember, it started at 20,000 and it dropped to 10,000. So what we're going to do to calculate this is we're going to do 20,000 subtract 10,000. So let's put that there, 20,000 subtract 10,000. And guess what? Since we're using, I could challenge you to figure out what one we're using, but we're using the subtraction property. Notice how it has the subtraction sign, which means I got to do it to both sides, but the other side is 0. So 20,000 minus 10,000 is 10,000. That was pretty straightforward. So now that I know how much it dropped, I want to write an equation that shows the relationship of miles to feet. So I know that it dropped 10,000 feet, but it also dropped 1.8939 miles. Those are the same thing. So this is really kind of like looking at the important information. So in math, we like to do a lot of highlighting. So we know it descended 20,000 to 10,000 feet. And that's the same thing as dropping 1.8939 miles. So in math, in order to represent sameness, we use the equal sign. So 1 point, then this should be 8939. M is equal to how many feet it dropped? Well, it dropped 10,000 feet. Remember, we calculated that in the first step. So I'm just going to write is equal to 10,000. And then here I have an equation that I can solve. I have a variable. I have a coefficient. Remember, it's supposed to be 1.8939, not 1.9839. I'm a little dyslexic, so that's why that's there. So in order to solve for M, I got to use the division property because this is attached to the M using multiplication, and the opposite of multiplication is division. So let's go ahead and divide both sides by, again, 1.8939. I did not put the right number. And then do that over here, 1.939. I'm going to use my little line tool to show that I'm drawing something. All right, and then if I use a calculator, you can check this on your own. Remember, the Desmos Scientific Calculator is like your God. So we have 10,000 divided by 1.8939. And that's going to equal 5,280. Oops, that's the wrong thing. So we just found out that something was equal to 5,280. So let's go back. What were we trying to figure out? Well, if I look in this question, I was trying to figure out how many feet are in a mile. So if I check this out, remember how many feet are in a mile? That was my goal. Well, I just found out that in 1 mile, remember this side represents miles, this side equals feet. In 1 mile, there is 5,280 feet. So that's my solution to this equation, is that in 1 mile, there is 5,280 feet. Now, could you have just Googled to figure out how many feet were a mile? Yes. Yes, you could. But in math, we're not always able to Google our answers. And so when we want to find things that are equivalent, this is how you would do it. You would try to figure out what one is equal to and what another variable is equal to, and then set them equal to each other to figure out what they are in terms of each other. So again, the essential question, how do you solve an equation one variable? If you have any questions today after the notes, please write them in the left-hand column, and we'll go over them in class tomorrow.